So use the following information to answer questions 9 and 10. So in an exam, this is actually really important that you take note of that. You might not think it, but really take note, because obviously when you get to the question 10, you might have needed something up here in this blurb. So just be careful. So a least squares line is used to model. So the least squares line, that's just another way to say, you know, that y equals a plus bx, or we actually say, you know, the response variable equals a plus b times the explanatory variable, okay? So that's what the least squares line is used to model the relationship between average temperature and latitude, and recorded at 7 different weather stations. The equation of the least squares line is found to be. So what you want to do, I'm just helping you go over things. That's the A value there, and it's also called, it's like the y-intercept. They're probably not going to call it the y-intercept, because we're obviously call this response variable explanatory variable. So you might hear them talk about it as the vertical intercept. So you might just put that there, just so you're remembering. And this other value here, this value here is the B value, okay? So that's the B value. And the B value is the gradient. And sometimes they talk about the gradient, or sometimes they call this, the gradient, the average rate of change. Okay, so just be wary, because sometimes kids see a question, it'll say what was the average rate of change in this scenario. They just want you to read the B value off, so just pop that in there so you know. Now obviously the sign becomes really important. It's a negative one, and so things that you can think about, it's sometimes good to think about what would have happened. So this would have been a scatter plot that had a negative line going down like that. All right, so let's go. So I'm just giving a bit more of a summary here. I know that's not the question, but let's go through. So it says the coefficient of determination was calculated. So really important, highlight this, and I like to visually put next to it, I would like to put next to it that is r squared, okay? You need to, the coefficient of determination, D1, determination, is r squared. So you've been told r squared. So then they're asking you for the correlation coefficient. So correlation coefficient is just the r value. So this one's just the r value. Okay, so, and please make sure that you're underlining this 3 decimal places or highlighting it, so then when you check, you know, that you're seeing that. It doesn't, in a multi-choice, not so much, but in a short answer, really important. Okay, so if we've got r squared, we can find r can be found by doing the square root of the r squared value. So 8,93743. So when you actually do the square root of a number, it could be actually positive or negative, because if you think about it, just for example, if you do -4 times -4, that equals positive 16, and so does 4 times 4. So that's why we say, so when we do square root of 16, you don't really know which one it was. So we often write the answer as plus or minus 4, you know, which one is it? Okay, in further, so when you do this, so when you do the square root of the r, you need to make a decision on which it is. So a decision has to be made, and you have information to look at that. So if you have a negative r value, you have a negative relationship, which means, so you might want to, we might write some notes down here. A negative r value equals a negative b value. Okay? A positive r value equals a positive b value. Okay? And also, you might want to put a little graph. A negative r value, you see a scatter plot like going downwards. A positive R value, you see the scatter plot going up. So in this answer, what's the square root of this number? Let's do that on the calculator. Okay, so what you can do, so this one's negative because that B up there is negative. So hopefully in the exam, you quickly cross them out, you know they're definitely wrong. Then you do the square root and you'll find that that's the answer. So you'll find the square root of that number. We just might pop that there. So this ends up equaling negative 0.945. Okay, so with this one, question 11, a study was conducted to investigate the effect of drinking coffee on sleep. Okay, so in the study, the amount of sleeping hours and the amount of coffee in cups is given on a day were recorded for a group of adults. And here's the thing. So up here is really important. You've got two variables here. You've got the effective drinking. So the drinking coffee is one variable and the sleep is another. So they said they wanted to see what the effect of drinking coffee had on your sleep. So what are they really looking at? What are they investigating? We're looking at what is affected is the sleep, isn't it? The sleep is what they're interested in, and then how that, how that is affected. So in the end, this is actually your RV value, yeah? We want to see what, if I have a lot of coffee, what will happen to my sleep, okay? So this one is your EV, and you might just want to pop in there, that's Y, and that's X, because that might help you. All right, so then when down here, when they give you these things, when they start writing the mean, and you've got the mean of sleep, it might be handy to start going, all right, well, sleep is Y. So that's the symbol for the mean, where they put the Y, and that, I'm going to put that. Then they gave me standard deviation, so we might write SY and standard deviation X. And then down here, they've given the correlation coefficient, which they said is R. Okay. So what you have, and they've asked you here, down here, they've said on average for each additional, so can you see this wording here? On average, for each additional cup of coffee, the amount of sleep. What did I say was represented by the words on average or average rate? There was a word I said yes. What did the question for? It was the mean. No. It was no. Was it the B value? So do you remember I said when they say average, they're often talking about the B value. So they're talking about, you've got this equation here. So you would have had sleep is affected by, and you would have had A plus B times the amount of coffee. Okay, that's what they would have done. They would have been, and then it would have done an investigation and found this thing. So when they say on average, they're looking for this B value. But I don't have the list of data. So there are these two other formulas that you're going to use, and they are on your summary sheet, which I'll just show you. I've popped your summary sheet on here. Yeah, so can you see here, there's in the middle there is they're talking about these questions. I've found another spot, but there it is, and they're the same as up here. So you've got the B value, and these are ways that you can find that B and A value if you don't have the list. So when you don't have the list, they'll probably give you this information. Now, can you see the formula? They have in the formula, it has R and SY, that's the standard, so that's what you're going to work out. So I just need to work out the B value. So B equals R times SY over SX, okay? So the R is negative 0.770 times SY, 1.12, over SX, 1.56, and that equals negative 0.55. So that's where the answer we get it decreased, because the word decreased. That means decrease. So that's how we get the decrease by things. So what's going to happen, you need those formulas and you've probably forgotten about them. They're very crucial. If you can't work out, I don't know how to get the equation because I don't have the lists, you're probably doing one of these questions and somewhere in the blurb they've given you those all this data. Okay, so the question 12, the table below shows the values of two variables x and y and the associated scatter plot is shown, and then they've said that x is the explanatory variable. So the scatter plot is non-linear, so we can see that because we can see that it's curved, yeah? So that makes it non-linear. Now, it's important to read what they ask here. A squared transformation is applied to the x variable. So into your calculator, you need to create an extra list of x squared. So we need to type those two lists in and then create an x squared list, which I'll show you in a minute. And then you need to do the lin reg and all that, and you need to go and get the a plus bx values so you can write it out. So let's go do that on the calc. So we've popped it into the calculator and we did lin reg where x list, we chose our x squared list, and the y list, we chose our normal y. Now, we ended up with the a value equaling negative 1.34 and the b value equaling positive 0.546. Now, once you've transformed your data, your equation has to represent that. So it'll actually now be y equals negative 1.34 plus 0.546. It's not x anymore, so it's actually times x squared. So you've got to put what you actually have changed it to. So that's why B's the answer and not A, because A doesn't have x squared on it. So whatever transformation you do, it has to go. So say, for example, all right, the following information, use the following information for 13 and 14. So really important to note that because you might forget about it when you're down there. Okay, and we have a time series plot for live ran each day and recorded 9 times. These times are shown. Okay, both the 3 median and 5 median smoothing are being considered for this data. Both of these methods result in the same smooth value on the day number 1. So what I'm going to do is I'm zooming in a little bit with you guys, okay? And I'm going to do, first I'm going to do the 3 median, sorry. So be careful. 3 median smoothing is done on the graph, okay? Median smoothing is generally done on the graph. So what you're going to do is when you're doing 3 median smoothing, what you do is you take your first 3 numbers, okay? And when you do, your first answer will be along this line here, yeah? So your first 3 median smoothing. So what you do is you get your ruler, and this is why it's good to have a clear ruler, and you go up, because if you have 3 numbers, the median one is the middle size one, isn't it? So if you look at it, this one is the lowest, then this one, the middle, and then this one's the highest. So if we were writing those numbers out, the median number would be along with this one. So what happens is it gets marked there alongside that one, and that's my first median smooth mark for the 3, okay? So I'm just gonna, do that, and then what you do is you would get the next 3. So my next 3 values are this, and I move my ruler up, and as soon as I hit the second highlighted green dot, yeah, that's the median smooth mark. So I go up here, I'm going up, it's gonna be along this 3, so I go up 1, 2. So it's in line with that one there, yeah? So then I'm gonna rub that out, rub that one out, and then we're doing the next 3. which is these three, okay? Up I go, 1, 2, so it's going to be in line with that one. So there's the next one. Oops, sorry. And then we're going to keep going. So rub that one out, put the next one. Okay, up I go, 1, 2, so it's in line with this guy. And then keep going. So this, it's going to take a little bit of a time, but just better to take your time. So we're doing the next 3. So I go up 1, 2, so it's in line with that one. Sorry, and then the second last 3. I'll keep rubbing out. I've done so many now, I might as well keep going. So the next 3, 1, 2, 3, so it's in line with that guy. It'd be there, and then the last 3, 1, 2, 3, this last 3, that last one is actually on the line. All right, so that's 3. So then we go off and we'd have to do 5 median. Okay, so off I go, and what I'm going to be doing is looking at the first 5. 1, 2, 3, 4, 5. If you had 5 numbers, what would, in order from lowest to highest, what would the median be on the third one? Good. So all you have to do is go up your highlighted until you reach the third one. So here I've hit 1, 2, 3. Yeah? So, and when you do 5 median smoothing, your first one's going to start on line 3. So you actually lost the first 2, didn't you? Okay, so that's all right. So I go up 1, 2, 3. So this first one is actually on that line. All right, then we're going to rub that out and we're going to do the next 5. Okay, so I'm going up on the line 4 and I'm going to get to the third. 1, 2, 3. So it's in line with that guy there. Okay, rubbing it out, doing the next one, the next 5. Up I go. 1, 2, 3. So it's in line with this one here. Okay. What am I doing? So I'm rubbing out the next one, putting the next one in. Okay. So I'm going up line 6. So 1, 2, 3. It's in line with, wait a minute, 1, 2, 3. It's up here, up on that next one. So it's a little bit, it's not quite on it, yeah. So then I do the next 5, which is going to be, it's going to be the last ones, isn't it? So what are we doing? We're taking that one off, and we're putting the last dot in, and up I go. 1, 2, 3, and I'm going up on 7. See how that was the same? So we're smack bang on the same. So there's my answer, which was day 7. Okay. Okay. Use the following information for 15 and 16. The time series plot below shows rainfall at a weather station in millimetres for each month. So the median monthly rainfall for 2017 was. So this threw kids off because they didn't give a number. But what they want, if you think about it, you have 12 months in a year. Okay, so if you're going, if you've got 12 months, if you had 12 numbers listed out, where would in order from lowest to highest, where would the median occur? Would it occur between these two? Yeah? So the median's going to occur between the 6th and 7th highest, or yeah, as you go up, or from the lowest or whatever. So what you do, you can still use your ruler and do the same thing. So I want to go up between 6 and 7. So if you go up, as I cross all these dots, I'm counting. So I've hit the first one, 1, 2, 3, 4, 5. Oh, whoops, I think I've counted 1, 2, 3, 4, 5, 6 and 7. So I've found between these two is 6 and 7. So I know that this is the 6th highest and this is the 7th. So it's in the middle of those two lines. So say here, and I've got my ruler, which is handy. So I've gone out and measured out somewhere like there. So if I look at that, that's like 110, between 100 and 110. So if it's somewhere between 100 and 110, which one is the only one that's capable? Is D. Okay, use the following question to answer questions 1 to 3 for this one. Okay, the times between successive nerve impulses in milliseconds was recorded and shows table 1 shows the mean and 5-number summary calculated using 800 recorded data values. Just sometimes I like to write that n equals 800 when they give me that, just so I know, because you might need it later on. We'll see. Okay, so the first question says, the shape of the distribution of these 800 times is best described as. So what you've only got the 5-number summary. So what you've got to think about is if you had a box plot, so if you had just like say ruled number line, so your minimum value is say 10. Okay, so if I go up and then your first quartile's on 70. So say if I went up and I go 10, 20, 30, 40, 50, 60, 70. All right, so first quartile would be there. So you'd have like this line. And then it says the median's at 150. So if that's 70, then I'd add another, say, 8. So I go 1, 2, 3, 4, 5, 6, 7, 8. So here would be my next one. This is 150. Now, from that's the median. Then from the next one, from 150 to 300, that's another 15 steps for me. So that would be, can you see, that's a big chunk. So that's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you can see you've got this big, long, this second one is longer. So really, so if you have a box plot with a smaller one and a longer one out like that, what type of shape is that? No, it's positive skewed. Okay, so that's okay. What we're going to do is you're going to say what type of shape is that. I'm going to show you on your summary sheet if I go to it. Okay, I just turn that round. Can you see here? I've drawn a box plot. Yes? Is it not like that? Yeah, so positive skewed. So you've got a little handy help. Now, if I look through, so I know it's positive skewed, so I'm going through these questions. I'm going to eliminate them, get rid of them, because you know it's not that. Now, what makes these two different is the one saying it's got an outlier. So I need to test for outliers. So here I've found off my summary sheet the test for outliers. Now, if I test for outliers, what I'm going to test for are these two, the 10 and the thing. 1,380 seems pretty big, so I'm going to test the upper fence first, okay? So I'm going to go test the upper fence. So the upper fence would equal Q3 plus 1.5 times IQR. Okay, so in this case, it's 300 plus 1.5 times 300 minus 70. Okay, if we do that on the calc. Okay, so I got 645. So because this is bigger, so 1380 is bigger than 645, this is an outlier, yeah? So I don't need to test the lower one. I've got one and it's just asking me that. So here's the answer. Question 4. The histogram below shows the distribution of forearm circumference in centimetres of 250 men. Assume that the forearm circumference values were rounded to 1 decimal place. Okay. All right. Now, the third quartile for this distribution could be. All right. So I'm going to go through, first of all, how we found, if we were trying to find the median in a histogram, because you need to know how to find this. If we need to find the median is at the 50% position. Okay, so if you have a total, you would have said, all right, 50% of 252, and you would have done that. So what is that? Is that? Yeah, 126. So what you would have see how this is frequency. You would have counted up all these frequencies until you got to the 126. Okay? So that's how you find the median, and that's often asked in an exam, how to do that. This one, in this question, they want you to find the third quartile. So if you think about your data, say you've got your data like this, the third quartile happens after 75%, doesn't it? You can either go that way, or this is from the start, or you could go in this way and from the end, and how far from the end would it be? It would be 25% in from the end, wouldn't it? Because it doesn't matter which way you go for the median. You go in 50, you could go in 50 that way, yeah? But for Q3, because I don't want to count up that many, I'm going to go in from the end. Does that make sense? So 25% of the data, so 252, if you do 0.25 of 252, I think it ends up being 63. Is that right? Just double check that. Okay, so it's 63. So I want to go in 63 positions from here. So this is the end. So what I do is start counting. So this one is 6. And once again, our ruler might come in handy in our exam for this. So this one's 6. This one is 3. This is 10, 10. Now, so I'll just put a few more. This one is, what's that? It's 14, 12, 14, 15. And then this one here is 23. Okay, let me start counting and see what I get. I've got 6 plus 3, that's 9, plus 10 is 19, plus another 10 is 29, plus another 15, so I'm up to 43. Add another. So if I add 23 to 43, 44 even, I end up with, what is that, 67. So it means it happens in somewhere in this column is where our third quartile is. So if you go down here, that's between 30 and 30.5. So I know the third quartile happens somewhere between 30 and 30.5. So if I go down here, which one? This is the only one between 30 and 30.5. Question 10, the variables study frequency in nightmare, low and high. Okay, when you have, this is definitely categorical. Okay, so if you go down to the flow chart that we've got here, so hopefully you have, it's not on your summary sheet, but I suggest you have something like this with your examples that you've struggled with. Okay, so it's definitely categorical. If you have a low or high, it has an order to it, doesn't it? If you move from low, you move to high. There's some type of order. So this one is ordinal. So maybe in your sheet you might have now that this is low and high, okay? There's an example of ordinal data. The other set of data you've got is yes, no. It is still categorical, okay? But no or yes has no order to it. So it is nominal. So I would suggest no and yes, you put this in. So you'll know if I get something where they ask a survey and it's no and yes, that's going to be nominal. So when they say what is these variables, when they say the word respectively, just means whichever one they listed first, they're putting first in your answer. So because the ordinal one was first, ordinal's first, and then nominal is the secondary. Question 13. A least squares line in the form of y equals a plus bx is fitted to a scatter plot. Which of the following is always true? So what you have to know is when you fit a scatter plot, and this is now written in the notes because they asked this. So here on your notes, if you look up under regression line, because they're the least squares line, it tells you how it's made. This is what the calculator's doing. It takes the least squares line is the line that minimizes the sum of the squares of the residual. So what the calculator does is you have this scatter plot, yeah, and it's creating this line where what they're doing is they're taking into account these little distances, but those once they've been squared. So we don't need to really go into it, but that's what it does. So you've got a little definition here of what it does. And then here, that's all they asked. Now, it said residuals in our definition. Residuals is a vertical distance. And then here you can see which one is the following is true. The sum of the squares of the vertical distance. So that's like saying residuals from the line. So you just had to be able to see that. So, okay. So the following information can be used for 15, 16, thank you. This is the rainfall. So, all right. Okay, the table below shows the mean rainfall in millimetres at a weather station associated with long-term seasonal indices. Long-term mean rainfall in December is missing. So we're moving into time series, okay? So this is definitely time series. Okay, so when you have time series, remember your seasonal things to remember. Your seasonal index should all add up. So when you add them all up, to how many? So because there's 12 seasons, these should all add up to 12. So that's an important fact. But here, what is missing, even though it says mean rainfall, that's just what they're recording. Don't think of it as like the mean. It's just the data. It's just what they're calling. You could just say rainfall. So what is missing here is the actual. So the actual rainfall for December. Rainfall for December. That's what's missing there. So just so you take note. Anyway, so let's have a look. This is what they often ask. They say to correct the rainfall in March. So when you see this to correct, so you might want to write, when you see the words to correct, and they might say for seasonality, what they actually mean is they want to deseasonalize the data. Okay? So to deseasonalize the data for March, the rainfall should be, so when we deseasonalize, we try to balance it out. Like we look at average and we're trying to bring it back to average. So if it's in like winter and there's a lot more rainfall, it would reduce and stuff like that. So anyway, if we go look at our deseasonalized value formula here, so we've got deseasonalized equals the actual over the seasonal index. So what they want to do is they want to say, how does March change? So what you want to do is you could put March in and then work out the percentage, but because they're talking about percentage, I'm just going to make up an actual. And you can, so make up actual of 100. So I'm making up an actual of 100 because we're talking percentages. Yeah? That's why I'm doing this. So if I go deseasonalize my 100 using March's seasonal index, which is 0.74. So if I do that on my calculator, if you do 100 divided by 7.41, so I'll just do that, you get your answer to be 134.95. Okay, so if you went from 100, and I'll just round up to 135, what have you done there? How has that number changed? Has it not increased by what? 35. And because I've used 100, see how it makes it easy? So then I can just say it's increased by 35. If you're under 1, you're under the average. So that means you would be boosting it up. So you should see increase. If you're above 1, you're above average. So when you deseasonalize, you should see it reducing. Okay, so that would be a quick way as well. All right, so obviously this information was used for 19 and 20, but 19 wasn't a problem. So let's go for 20. So the time series below displays the airline passengers in the 1,000 each month during the months January to December in 1960. Okay, during the periods January to May in 1960, the total airline passengers was 216. The 5 mean smooth number of passengers for March in 1960 was. So what you need to do is you just have to do, this is now, be careful, this is they want 5 mean. So 5 mean smoothing means you add them all up. So when you have mean smoothing, you add them all up and then divide by obviously 5 or whatever. Okay, so this is when you only have an odd number, you just have to do that. So all you had to do is because you're doing March, so March, remember you need to go, because it's 5, you need to go 2 below it and 2 above it. So there are the 5 months that you've got. And so I measured off all those numbers. So I would add all those numbers up and divide by 5, and that's how I got that answer. So I know before I said mean is normally done with a table. This is how they're throwing it around now a little bit. Okay? So just be careful, read the question. Probably I would suggest it was done poorly because kids have seen a graph, they've seen smoothed, and up they did the median, where it's the mean, okay? So be careful.